Welcome back to MooMooMath. Today we're going to look at the volume of prisms, or we're looking at the volume prisms and cylinders, but specifically at Cavalieris Principle and how to find the volume of composite figures. Okay, so let's start with a quick review. Find the area of each figure, round to the nearest tenth. You need to know this stuff for maybe a test or a quiz coming up. Okay, an equilateral triangle has an edge of 20. So we're going to try to find the area. Okay, so we've got an equilateral triangle with 20 on each side. How do you find the area of that? Well, it's 1/2 base times height, correct? Okay, so we got the base, that's 20. But what's our height? Let's draw it in. Okay, on an equilateral triangle, what happens to this base? It cuts it in half. So we end up with 10 over here and 10 over here. Well, once you get that, what kind of triangle is this? Left side, that's a 30, 60, 90 triangle. So if that's a 30, 60, 90 triangle, this angle was 60, but I cut it in half, so that's my 30. That means this side that's 10 is my short leg. This 20 is my hypotenuse, so I need to know the long leg. Short leg to long leg, what do we multiply by? We multiply by √3, and there's our height. So we're going to have 1/2 of 20 times, 10√3. Now I started writing 10√10, but it's 10√3. So half of 20 is 10, and 10 times 10 is 100√3. And that would be the area, and that's in centimeters squared, right? Because it's area. Okay, so that's how you do that one. Do be familiar with that one. Find the area of a regular hexagon. Well, we haven't done hexagons, I don't think, in this lesson, so don't worry about the hexagon. A circle with a radius of 6.8. Okay, what's the area of a circle? Pi r squared. I hope you're thinking. Okay, so if the radius is given, it's very easy. We just take pi times 6.8 quantity squared. So let's grab our calculators, and this would be one you'd use the calculator on. 6.8 squared would give us 46.24. So 46.24 pi, and that would be inches squared. So that one's pretty easy too. And then a circle with a diameter of 7. Now remember, we're dealing with circles again, and the formula is pi r squared. So if our diameter is 14, what's our radius? Our radius is 7. So pi times 7 squared, or 49 pi feet squared. So there's a quick little review. And again, I don't think we're going to do hexagons this summer. We just don't have enough time. Okay, so let's talk about Cavalier's Principle. Okay, the volume of three-dimensional figures is the number of non-overlapping unit cubes of a given size that will fit exactly on the interior. So we're talking about the inside space. So you can see this pyramid or prism, and then you can see this prism. Well, they're the exact same thing, only one is slanted. We also have another word for that. Oblique is another word. And Cavalier's Principle says that if these two figures have the same height, so top to bottom, same height, and they have the same cross section, so their bases are the same size, then they have the same volume. So really, a slanted one, you treat exactly like one that's straight up and down. You just have to be careful to find this height. Okay? Now, let's put this to practice here. Oh, so down here you've got the formulas. The volume of the prism with a base of B, big base area B, and a height of H is volume equals B, big B times H. And then a length, width, and height, right? Our base area times our height. And then when it's a cube, side squared times height. But they're just going to be oblique sometimes. So Cavalier's Principle is just saying the oblique ones are calculated the same way. So here's an example of one with CDs. And it's really a great example, or coins, or another good way. If you stack up you have two stacks of CDs. Let's say you have 15 in this one, and 15 in this one, and this one slants. Does the volume change? No. It's the same volume. It's just slanted. So there's kind of proof of how to do that one. And remember, the volume is base area, which in this case CDs would be pi r squared times the height. So pi r squared times the height. But notice on the oblique one, the height is that altitude from the top corner down. So, okay, let's put it into practice here. So we're going to find the volume of this oblique cylinder. So we need to know pi r squared h, right? Pi r squared h is our formula. So our radius, what's our radius here? It's 9. So 9 squared. And what's our height? Well, that's given to us. That was really easy. 14. Sometimes that won't be given. You might be given this, and you might have to work a Pythagorean theorem to figure out your height. So always keep Pythagorean theorem in your back pocket. Okay, so let's go back and calculate. Well, we know 9 squared is 81, and then times 14, I don't know that off the top of my head, so it's 1134. So that's 1,134 pi, and this is a volume, so it's inches cubed, 3-dimensional. So there you go. There's our first one with an oblique. Okay, so we're going to do one without a picture. Find the volume of a cylinder that has a base area of 121 pi centimeters squared and a height equal to twice the radius. Find the volume in terms of pi. So if we know the base area is 121 pi, that was given to us, what would be the radius? Well, base area of a circle is pi r squared, and that's equal to 121 pi. So let's solve for r. Well, let's divide both sides by pi, right? Or just cancel pi off of each side since they have the same thing. So r squared is 121. So what's our radius? Our radius is square root of 121 or 11. Okay, now it says that the height is equal to twice the radius. So what's twice the radius? Well, the radius is 11, so the height must be 22. 2 times 11 or 22. So now we already have the base area, so this is going to be easy now. Base area times height. Base area is 121 pi times a height of 22. So let's grab our calculators. 121 times 22, and that's 2,662 pi. Don't forget your pi. Leave your in terms of pi, and then this would be in centimeters, and it's volume, so it is cubed. Okay, so that was a working backwards one, which we're going to have to do a few of those to kind of work backwards towards. Okay, this sheet just has some answers on it, but let's keep going. Okay, let's look at this oblique, and let's talk about what this is called. Well, the bottom of it is what shape? It's a rectangle. So this is a rectangular prism, but is oblique. So it's an oblique rectangular prism. Okay, so we need to find the base area, don't we? So the base area is just going to be length times width, which is 4 times 3. And then the height is not the slanted part, but the straight up and down part, which is 1.5. So let's see. The volume would be 4 times 3 times 1.5. Okay, so the volume is 18, and this would be feet cubed. Okay, now what happens if we double all the dimensions? So what are the dimensions if they're multiplied by 2? Well, this side is no longer 4, it's 8. This side is no longer 3, it is 6, and this height is no longer 1.5, but it's 3. Okay, so we've taken each side and multiplied it by 2, haven't we? Okay, what do you think it's going to do to our volume? Is it going to double it? Is it going to triple it? What's it going to do? Well, let's just crank it out for a second. Plug into your formula a length times a width, 8 times 6 times your height, which is 3. And that's 48 times 3. Let's see, 48 times 3. Should know that one, 144. Wow, it's a lot bigger, isn't it? It's not twice as big. It's not 4 times as big. How many times bigger is it? Well, 144 divided by 18, it's 8 times larger. So it's 8 times larger. Why would it be 8 times larger and not doubled? Well, we did a length and a width and a height all by 2. So what's 2 times 2 times 2? It's 8. So it increased each dimension 3 times. So it's 3 times that dimension cubed. And that's going to come into play in just a moment. Okay, so let's keep going. Let's look at composite figures. Okay, composite figures. The volume of a rectangular prism, it says find the volume of the composite figure, round to the nearest tenth. So what kind of figures do we have? Well, at first you might say, that's a pyramid and a prism on the bottom, but be careful. The top is also a prism because it's got parallel bases, but the bases just happen to be triangles. So what you're going to do is you're going to find the area of the rectangular prism on the bottom. And we know that one's easy. It's length times width times height. So let's do that. Length times width times height. So that's going to be 8 times 4 times 5. And that's going to be 40 times 4, which is 160. Okay? So 160 cubic centimeters. Now let's find the volume of the regular triangular prism. This triangle right here, okay? Do you see how they're parallel to each other? And that's how you can tell. Okay, so we've got to find the area of an equilateral triangle, don't we? We did that in the warm-up. So let's draw our altitude down. We know that cuts that into 4 and 4. And remember the rule, this is a short leg, this is the long leg. So that is 4 square root 3. So let's find the area. It's 1/2 the base. Well, we're going to use the whole base of the triangle. 1/2 of 8 times the height, which is 4 root 3. So half of 8 is 4, and 4 times 4 is 16 root 3. So that is now my base area. So base area times the height. Well, now the height is this part, right? Because here's my parallel side. So times 5, and what's 16 times 5? I believe that's 80, isn't it? Okay, yeah, 80. So that's going to be 80 root 3 cubic centimeters. Okay, now, here are my 2 volumes. I'm putting them together, so I'm going to add them. Now, can I add these together? Not in the form they're in, so there's your answer in exact form. Now, if you have a decimal form, you can go ahead and type it out as 160 plus 80 and put in the square root 3, and it should give you the decimal answer. So the decimal answer is 298.6 cubic centimeters. But if you want the exact, because we'd have to round this off, so that one's not exact. Here's the exact answer. So if you're asked for exact answers, leave them as radicals. And if you're asked for estimated, you write it as a decimal. Okay, let's look at a couple more of these composite figures. Okay, this next composite figure is a rectangular prism topped off with a cylinder. But what do you notice about the cylinder? The cylinder is only half of a cylinder. So let's look at this rectangular prism, and then we're going to have to figure out that cylinder part. So the rectangular prism is going to be length times width times height, or 9 times 11 times 6. So 99 times 6 is 500 and what? Something, almost 600. 6 short of 400, right? 594 cubic millimeters. Okay, so that part's easy, the rectangular prism. Now let's look at the cylinder. Okay, a cylinder's volume is pi r squared times height. But what are we going to do with that cylinder since we only have half of it? We're going to divide it by 2. Okay, so let's go back and figure out our radius and our height. Okay, what's the radius of this cylinder? It's half of this side, isn't it? Okay, so this is 9, and this is 9, so it's going to be 4.5. So it's going to be 4.5 squared. And now the height is this height, which is 11. Then we're going to take all that divided by 2. So let's crank this out. Let's see, 4.5 squared. That's going to give me 20.25 times 11. That's going to give me 222.75 pi divided by 2. So let's just divide that coefficient by 2. And that's 111.375. And I still have my pi in there. Okay? So that is the volume of that cylinder part. Now we've got to take these two and do what? Add them together. So I've got 594 plus 111.375 pi. Now we usually round to tenths, so I'm going to round that 3 to what? A 4. So 594 plus 111.4 pi. And because that has a pi, I can't add them together, and I just stick my units with it, which is millimeters cubed. And there we go. Okay, now let's look at composite figures where we've got a hole in the middle. Okay, so we've got a cylinder, and in the middle of it, cut out of the center of it, is this prism. So instead of adding the two quantities together like we did up here for the composite figures, we're going to do what? We're going to subtract, because we're going to take the volume of the cylinder and we're cutting out the volume of that rectangular, or I'm sorry, that's actually a square prism. So let's first find the volume of the cylinder. Volume of the cylinder is pi r squared, base area times height. So our radius is easy. It's given. It's 3. So that's going to be 9 pi times 5, or 45 pi. Okay. Now, I need to find the volume of the square prism. I'm not given a side of the square. I'm given this little measurement, and that surely is not the side. So let's look at this from looking straight down. I'm changing this to a bird's eye view. So this is now 3. Okay, which means this is 3. Okay, what do we know about a square? These are right angles, and when we draw this in, it's going to become a 45, 45, 90 right triangle. So that means this side is the hypotenuse of the 45, 45, 90. So it's 3 root, remember the rule? 3 root 2. You multiply the leg by root 2. So that's now the side. So let's see. The volume of a square prism is going to be base area, which is side squared, times the height. And then my side is 3 root 2 squared times the height. Well, the height is still 5. And so 3 squared is 9, and square root of 2 squared is just 2, so that's going to give me 18 times 5. What's 18 times 5? Gives me 90. So that's going to be 90. So the volume of that square prism is 90. Now, what do I do with these two since one's cut out? Instead of adding this time, I am going to subtract them. So it's going to be 45 pi minus 90. Now, you may think, oh, 45 is smaller than 90. How could you subtract this? But watch. 45 times 3.14. It is not less than 90. It's 141.3. Minus 90, 51.3. If you were asked for the decimal. If you're asked for exact, you stop right here and just throw your units in there as centimeters cubed. If you're asked for an estimate or a decimal, you would round it off to this point. So there you go. There's one of those where you're subtracting composites. And here's a quick little, I printed this out for myself to make sure I did it correctly. And then the last one I want to do with you is this composite. Yeah, this is the last one, right? Yep. Is the composite of a cylinder inside a cylinder. So it's like a washer. It's like a stack of washers or stack of CDs. Same concept. You're going to do the volume of the large one and subtract the volume of the small one. But this time, they're both circles, so it's going to make the answer easier. Okay, so we got a circle minus a circle. So think about your shapes. What are you subtracting? So pi r squared is my formula times the height minus pi r squared times height. So the formulas are the same. The only difference is going to be what? The heights are the same, but the radiuses are different. So what's the radius of the larger one? Well, that's 18. So it's going to be 18 squared times 12 minus pi. And on my radius of the small one is 9. So 9 squared times 12. And let's crank this out. Okay, 18 squared times 12. That's going to give me 3,888 pi minus, okay, 9 squared is 81, and 81 times 12 is 972 pi. So now I'm going to subtract these. Can I subtract these? And the answer, I hope you're saying, is yes, you can, because they both have a pi with them. So 3,888 minus 972 is 2,916 pi, don't forget your pi, inches cubed. And that's how you find the volume of composite figures when one is inside the other. So when they're stacked on top of each other, all the way up, you add. When one's inside the other, taking out its space, you subtract. So hope this video was helpful.